This is a quick video description of this problem. The target function that you're asked to write is called deduplicate. So basically, your input is an array of characters. These are capital or uppercase English characters. Your input is an array of these characters. Some of those are duplicates to each other, meaning you can have double A's, you can have double K's, and stuff like that. But the important thing to note is we only care about the consecutive duplicates. Basically, characters are sitting to each other, next to each other. They are the same, right? So your deduplicate function, namely D, right? DE means to remove. Remove duplicate removes these consecutive duplicates. So if you have an input, say A, B, A, even though A and A's, right, there are two A's in there, these characters exist inside this input. They are not consecutive. They're not sitting to each other. So there is really nothing to dedupe, right? However, if you have an input that has A, and B here, then A, in this case, these characters are consecutive, right? So they're sitting next to each other and they're duplicate. So your dedupe function, right? Let me use a different color, will then get rid of these, right? So what you end up with after dedupe is this string with only a character B in it. Now, B is not a duplicate. There's only one, right? So when you have one letter character, there is nothing to dedupe further because there is no duplicates anymore, right? Regardless whether they're consecutive or not. So this is really it. Given KCCK, so what will happen is your first pass, right? This involves obviously looping through the entire string input. You will see that KCC, in this case, C and C's are consecutive duplicates, right? So the very first pass, the first iterations, right, is your KCCK will then become K and K, right? Actually, this is the 0th iteration, right? The first iteration is actually here. This is the reason why you're getting into KK. Okay, so after you remove the C's, right, you end up with K and K, right? But K and K itself, this is a string. This is the second pass, will give you basically an empty string because K and K are both deduplicates, right? So you can imagine, right, this dedupe iterates, right? It basically just keeps going until there is nothing to remove further. So this is the interesting part, right? This is what we call empty string, right? So if you read the definitions here, the empty string is basically a pair of double quotes with nothing in it, right? You do not want to leave any space in it as well as its value. So if you do string s equals, right, this gives you an empty string. Now, this empty string still takes up memory space, right? 24 bytes, and it's just got a value of empty, right, in it. Now, actually, no, this is not the same as null, right? If you do null in it, this is a string with a value, right? Null, null, as its, right, 4 characters in it. So this is not the same as null string. You can also, and this empty string is not the same as a null string either, right? So null string means you set s equals capital NULL. So what is so MUL? NULL is 0. Okay, but you can't do that either because if you just instantiate a class, this null is a value assigned to a string pointers. Okay, any pointers. So given that s is not a pointer, we can't really do that. So there was a prior video illustrating this s being assigned a value of null, being a valid return. No, this is not. So this is a correction to the prior videos, whatever were set there. So let's look at the other example. Before we do that, let's clear the screen a little bit so we can see better. If you have ZZZ, right? So ZZZ, upon first pass, right, of your dedupe, it will eliminate, right, the first two. But it depends on, if where your iteration begins, right? If you begin from behind, from end to the begin, you may dedupe the very first two. But the point is, after your first iteration, you end up with Z, right? There's really nothing. But Z itself is one character. There's no duplicate. So there's nothing to dedupe. So the answer is Z, right? Now let's look at KKCCD. Now KKCCD. So after the first iteration, you could be eliminating this, right? It depends on what your logic is. If your logic just keeps going until you have nothing to iterate further, then upon the very first pass, right, you end up with D, right? And that's it, you're done. Or if your logic basically calls for dedupe only once, and then your first iteration is going to give you CCD, right? Does it make sense? And CCD is going to be D, right? Because C and C could be eliminated. So it depends on what your logic, right? Your logic could be this one, right? Where it basically just goes through, blanket style, right? The entirety of your string, or your logic could be, let's do it, small chunk at a time. Just do one erase, and then move on, and it just keeps sanitizations happened, in a small chunk. So that's all fine. That's your choice. You can use string. There is a method called erase to do that. So C++ string is immutable, right? Because in this case, our string input is not a const. Okay, so we talked about what a const is. This is a keyword that says the input is, or if you apply const on top of the input, this is a constant string. You cannot mutate it. You cannot change it. You cannot modify it. You cannot update it. But we're not talking about const here. So you can use st, right? S dot erase, S being your string instance, to kind of move forward with your dedupe, right? That's how you proceed with this problem. There are other ways too. If you want, you can create a temporary buffer, a string buffer, and you just copy, right, the remaining untouched portion of your string into it, and then iterate through using the new buffer. So whichever way you proceed, totally fine. Just make sure that your code works. So given the above example, you can come up with more of those. Let's go through some constraints and assumption as well. So lots of students keep asking, what's constraint, what's consumption? So this means it's already given, okay? This is given in the problem. So meaning if I said string inputs, right, consists of at least one English alphabet, this means that input is never going to be empty, and the string is never going to, the input string is never going to be a null, right? So you do not have to check it, okay? So this is already assumed, okay, implied. This also said that your input is only going to be the uppercase, right, English characters, alphabets. So there's not going to be a small letter A to the Z, right, or any numbers, Roman numeral numbers. So do not, right, need to check those either. Your input string is at most 100 alphabets. So I can have a test case that has 99 alphabets in it. It's English uppercase alphabets in it. So your test case, your logic has to support that. But anyway, this is not important. If your logic is correct, it can go up to 200 alphabets, 300, 3,000, right? Doesn't matter. So the function returns a non-reducible string, right? So this means there's no more duplicates left. Okay, so this is C++ we're talking about. If the reduced string is empty, right? So in the case where we have AA, BB, or CC, right? Your return should be an empty, right? Which is a double quote, okay? Double quote string. And that said, your starter code is here. Please copy and paste this as a starting point. This is not going to compile because this deduplicate is supposed to return a string and there's none here. So, but at least you will not be making a mistake on the spelling, right, of your function signature, because this is usually the source of issues here. Your autograder won't be able to compile. So you would have your test code looking like this. This target function will be tested as such, but you can write whatever you like here. A lot of times, if you want, you can do deduplicate, right? And then whatever this method is, right? And then you can do equals you know, actually in this case, if this is A, right, the result is an A. So, you know, if you write this out as a conditional and see out the result of this conditional, you should be getting 1, right, on your output. So yeah, I mean, you can write your test case that way inside your main. It's totally up to you, right? I don't really look at your main, but I care about your implementations here. Yeah, so you have your function implementations sitting on atop your main, right? In this, and make sure you include your code and also API documentation, which is available in your syllabus. So go into syllabus and check out how API documentation is done. We'll take it from there. Aside from the pound include, you don't really need anything else. String, IOString, these are important. IOString allows you to see out, right? But this string is necessary because this string library is for C++ string. Okay, so this concludes our discussion of this video for this problem set.